This is the second part of 4.5. It's a second derivative test for relative extrema. So a couple of things. Remember what relative extrema are. So relative extrema are maxes and mins. So find relative max and relative mins. A couple of things. This test does not require a second derivative number line test. That's really important. You're not doing what we just did. You will not make a second derivative number line test. You're also not finding points of inflection. You're finding max and mins. So what we're going to do is this. We're going to find when the f prime, we're going to find our critical numbers on f prime. And then we're going to plug those critical numbers in f double prime and analyze their concavity to determine if the function is relative mins or maxes. So an example of this is this. Let's say we have a function like this. Okay, if this would be a critical number in my first derivative, that's when the first derivative is equal to 0. Well, if I take that x value and then I plug it into my second derivative, if it comes out to be positive, that means the graph is concave up. If it's concave up, then we have our answer that it has to be a minimum, right? If it's concave up. If I take this one, I take my x value and plug it into my second derivative. If it comes out to be negative, that means it's concave down. So we can tell you that that graph is, that means it'd be a maximum if it's concave down. So the second derivative test does not always give you an answer. And that's the drawback to it. That's why we don't always do the second derivative test, right? Usually when we find maxes or mins, we do the first derivative number line. It always works. It will always tell you whether it's a max or a min. Sometimes the second derivative comes out to be 0. When it does, you cannot tell if it has a max or a min. So for that reason, we don't usually do the second derivative number line test to determine max or mins. Usually we do the first derivative number line like you did back on 4.4. So long story short, only you use the second derivative test to find max and mins if it actually asks you to, or sometimes the information we're given will require you to do it this way. So let's go through a couple of examples. So this says, use the second derivative test to find the relative max and relative min points for that graph. So in this case, it's telling us to, right? It's telling us to use the second derivative test. Okay, so first start by finding your first derivative and finding your critical numbers. So let's find the first derivative. F prime of x is equal to, that would be negative 12 x to the third plus 12x. So you want to find out when this function, when this first derivative is undefined or equal to 0. It's a polynomial, so it's never undefined, but it will equal 0. So let's find that. So set it equal to 0. You could factor out a negative 12x. That would leave me with a x squared minus 1. So it's equal to 0 when x is equal to 0. And then this one will be plus or minus 1. Now normally we'd put that on the number line, the first derivative number line, and we would test the intervals to figure out if they are maxes or mins. In this case, though, it's telling us to use a second derivative test. So what I want to do is find out, is it concave up or down at 0? Is it concave up or down at negative 1? Is it concave up or down at positive 1? So to do that, we use the second derivative. So let's find the second derivative. So if I plug 0 in, well, let's actually find the second derivative. I guess that would help. So that would be negative 36 x squared plus 12. Okay, so I'm going to plug in 0. So if I plug in 0, I get a positive 12. That means at 0, it's concave up. Right, my second derivative is positive. Let's plug in negative 1. So I plug in negative 1. That would be negative 36 plus 12 comes out to be negative 24. That's concave down. Plug in 1. That also comes out to be negative 24. So that means it's also concave down. Now what we're trying to find is if there's mins or maxes at 0, negative 1, and 1. So think about this for a second. At 0, it's concave up. So if it's concave up, that means at 0 that it is a min. So it has a relative min at 0 something. Okay, at -1, it's concave down. That means it has to be a relative max. So max at -1 something, and then at 1 it's also concave down, so it's also going to be a relative max. So go back, now it does say points, so let's go back into our original function, plug those numbers back in to find the y values. If I plug 0 in, I get 0, so a relative min at 0.00. If I plug -1 in, that'd come out to be -3 plus 6, which is 3. If I plug 1 in, I get the same thing. So there are my relative max and relative mins. It works really nice. Now the problem is sometimes when you try this, you won't be, first of all, sometimes you can't find the second derivative very easily. It takes more time than just doing the first derivative number line test. The second thing is that sometimes the second derivative will equal 0, and then you can't tell whether it's concave up or concave down at that point, whether it has them, and so you can't tell if it has, if it's a max or a min. So we're not always going to do this test. You're only going to do this test when it asks you to, or if there's not enough information to do it on your own. Okay, let's do this last example. So it says g of x is a function with some derivative values shown on the table. Find the x values of the relative max and the relative min points when possible. Okay, so I want to find relative max and relative mins. I start with the first derivative and I find out when is it equal to 0 or when is it undefined. So look right here. Here's my first derivative. It's equal to 0 there, 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 and there. So those are my possible relative maxes or relative mins. Let's put that down. Those are my critical numbers. So critical numbers at x equals -3, -1, 0, and 2. Okay, now look at the second derivative. And I can't use the first derivative number line because there's no way to find those. Sorry about that. So I'm going to look at the second derivative instead. So you look at -3. At -3 it's equal to 4, and at 2 it's equal to 3. They're both positive there. So if their second derivative is positive, that means concave up. So at -3 and 2, it's concave up, which means those are minimums. If you want to put your reasoning, you would say because g prime is equal to 0 and g double prime is positive, which means it's concave up. So that means these would be mins. Okay, and then it has a max. You'll look back up here. Right here, the second derivative is negative. That means it's concave down, right? It's concave down. So that's at x equals -1. It has a max. And my reason would be because g prime equals 0 and g double prime is less than 0, which makes it concave down, which makes it a max. Now the one I want to point out is this one right here. At this point right here, it can't be determined. The reason why is because even though it's a critical number, the derivative is equal to 0. The second derivative is also equal to 0, so we can't tell if it is concave up or concave down, which means we can't tell if it's a max or a min. It could be, it might not be. We just don't have enough information to determine it. So usually there's 2 times when you use the second derivative test. First one's when they ask you to. The second one is usually when they give you a list of points like this. So there's no way to do the number line test because we can't test our intervals. So instead we use this second derivative test to figure those out. Okay, and that's it for the second derivative test. Thanks.